Welcome, Solid Edge fans, to another edition of Acuity's Lunch and Learns for Solid Edge. This month we're going to explore some of the enhancements that Siemens has given us in ST6. And this will be followed up next month with the conclusion of this two-part series. This first part of the series we're going to cover enhancements in sheet metal and part, and then next month we'll close this session out with assembly and draft. And we're not going to cover all the enhancements in all of these areas. There's literally hundreds and hundreds and hundreds of enhancements, and we just don't have time or bandwidth to cover all of them, but we'll give you some highlights of some of the more significant things. My name's Mike Ritzer. I'm an application engineer for Acuity Solutions, and I'm pleased to bring you this presentation. These are some great enhancements. This is a really nice release, very strong release, and I think you'll agree. And again, on behalf of Acuity Solutions, welcome, and we'll take a look at first some of the enhancements in the part environment. Some of these enhancements that Siemens has placed into ST6 cross all of the environments within Solid Edge, or most of them. And so I'm going to start out just by giving you some general enhancements and some goodies that they've put into Solid Edge before I jump into part modeling and the enhancements in the part environment. So again, these are some general enhancements. First off, one of the nice things that they've added in here, if you're kind of a person who likes to share their information and knowledge with other Solid Edge users in the world, ST6 now gives us the ability to record video right from Solid Edge, and this is in fact how I'm building this Lunch and Learn, is by using the new functionality within Solid Edge ST6. And it also gives us the ability to push those videos up into YouTube. So if you've got a YouTube account, you can create these videos and then you can push them up onto YouTube very easily, right here in Solid Edge, without having to leave Solid Edge. So the record button here, and there is a Pathfinder sidebar, edge bar, called YouTube, and this allows you to search for items within the YouTube environment and look at them. And then it also allows you to record from here and then upload those things right from, again, from Solid Edge. The buttons down here also give you basically the same functionality as the edge bar, so I'll just be using these today. So if I click on the record button, you'll see right now that it's showing the recording function, because I'm already recording this as we're doing this. But when you open this up for the first time, before you start recording, there's settings in there that you can set. A couple of the key settings in there would be, there's a checkbox in there, and if you don't check it off, you don't get the audio portion of it. I learned that quickly. So you have to check off audio. By default, it doesn't provide the audio for some reason. I don't know why. It just records the video, but it will not record the audio unless you check that checkbox. And one of the other key things in there is that there's a area in there that you can tell it to record just the window that we're looking at. In other words, just the carrier assembly out here, or you can show the whole application, Solid Edge application. And in my case, that's what I want to show you, because I'm going to be going to different icons and tools within the Solid Edge environment, and I want to make sure that everybody can see that. So those are a couple of key settings that you want to watch for when you're starting up your YouTube recording, especially the audio. And I don't know why by default it's turned off again, but you want to make sure you check that checkbox and include the audio. So to start it, you can do a Shift F9, or you can click this button, and to stop it you can do a Shift F10, and that stops the recording. So once again, I can't show you that box because I'm right in the middle of recording, but once my file has been created, then I can click on this and push this up to YouTube. It will let me sign in. It will let me find the WAV file that I want to push up. In fact, you could probably push any WAV file up with this, not necessarily a Solid Edge file, but you can push anything up there. Here's your title and description, and then you can put your tags for searching in there. You can allow only private individuals to see it, or you can make it public. So you also have to check off the fact that you acknowledge that this is the content of this is deemed acceptable by the YouTube board, and it's allowed to be publicly displayed. So very nice enhancement. Yeah, so I think that's probably about it. Well, when you get done then, and again I can't show you because if I stop the video then I'm stopping the recording of the Lunch and Learn. But once you stop the video, then there's a save button, and in there you can save it to a WMV file, or I think there might be a couple of different formats that you can save to. And that creates the file, and then you can either push it right up directly again right from here, or you can wait till later and push it up after you've perhaps edited it or done what you want to do with it. So very nice enhancement, and I think it's very exciting. Another enhancement, a general enhancement that they've added to Solid Edge, this is primarily, I think, mostly for new users. They've added a couple, 3 or 4 themes in here. And if you're not familiar with themes, themes are how we tell Solid Edge how we want to look at our environment. And we've covered this in the Lunch and Learns in the past, and I think it was about ST3 where we could start to customize our panels up here and add and remove icons and functionality and rearrange things, and those all became what are called themes. And the default theme is the one that's the baseline. You can always go back to the default theme, which is the out-of-the-box setting. But you can see I've created several over the years, and these all propagate as you install later versions of Solid Edge. They propagate to the later versions, and so you don't lose any of those themes. But once again, Solid Edge and ST6 has added these 4 up here. So if you're in need of some assistance, you're a casual user perhaps, you might use it once a week or twice a week or whatever, you might select some assistance theme, and what that will do is it will change everything up here. It will reorganize your edge bar and give you some other enhancements, and it will also pop up things as you're creating stuff. So again, it's for the casual user, someone who may not use it a lot. You've got maximum assistance. This would be someone who is just starting up with Solid Edge, might use maximum assistance to get the most out of information from and help from Solid Edge as they work through their process. So you can give these a try and see if any of them fit better with the way your workflow goes. I'm just going to go ahead and set mine back to my typical theme, the last theme that I saved, and so I've gone back to that. So that's kind of a nice thing. The other thing that they've added in a general manner is the steering wheel has gotten a little bit better. I say a little bit. It's quite a bit better, and I think basically they got rid of the secondary and the primary pointers. As you can see, the pointers are now all the same size. I don't know if you remember, but this pointer here was a shorter pointer, and so they've made them all the same size. And then also the reference plane inside here, the one that you can hold down Shift and you can change the order or the angle of the steering wheel, that's a little more apparent than it used to be in previous versions of Solid Edge. It was kind of hard to see that. So it's a little easier to see that that reference plane in there. So, and again, by clicking, holding down the Shift key and clicking that center plane, you can get it to reorient the steering wheel in another on another plane. So these are all nice enhancements. Another thing that I think that they've done that I really like a lot is their help has gotten significantly better. And instead of having help libraries that are installed and never change, they've gone to a support system online so that they can keep the help more up to date and more accurate as things go on. So the only downside to this is that you have to have an acceptable link out to the internet. But all of these things are available now, and there's much more detailed information about creating things and how to do things, and I think it's a lot better than it's been in the past, probably than it's ever been. So take a look at the help. I think that's a real significant improvement in the Solid Edge ST6 enhancements. Okay, so let's move on to the enhancements for ST6 in the Solid Edge part modeling environment. First off, let's talk about goal seeking. Now, goal seeking has been in Solid Edge for many years. If you didn't know it, in ST, oh gosh, no, it was way before ST came along. It was in the drafting portion of Solid Edge, and it would allow you to do goal seeking on a 2D basis. So if you had a sketch, you could do a goal seek on, for instance, the area within a sketch, perhaps the perimeter of a sketch. It would allow you to vary and goal seek on dimensions and vary a dimension based on a goal that you're trying to achieve for a certain dimension. And that's been around for a long time in the 2D environment. But in ST6, they give us the ability to do goal seeking now in the 3D environment. So I've created a Solid Edge synchronous part here by creating a region, and I'm going to go ahead and extrude that back a distance. And this is kind of a generic application. It may not seem that it's a real-world application. It's kind of made up. We make these examples up to try to drive home the ideas and the concepts within these tools, and leave it to you to apply them to a real-world situation. But the situation here is that I've got a profile of a block, and I've got a distance for the shape that goes back in space, and I want to vary this thing to the point I want to make it as long as possible but keep it still at a 60-pound weight. So I want to make this guy change so that it gets bigger and bigger until it reaches a point, or smaller and smaller until it reaches a point where it's 60 pounds in size. I'm just going to start off with a 12-inch block for now. So the first thing I've got to do here is I've got to give it a material. So I'm going to go to the properties, and I'm going to go to the material table, and we'll make this out of aluminum, say 1350. So what I want to look at here, the goal that I want to achieve is a 60-pound mass. So the mass of this thing is what I really want to look at. Now, we'll start out by looking at the variable table. The variable table only has just a couple of things in it. It's got my linear dimension, it's got a little bit about the physical properties, the density of the material, but it doesn't list my mass. And the reason it doesn't list the mass is not because I don't have it turned on in my filter. The filter has physical properties turned on. The reason it's not showing up in my variable table is because I haven't done an analysis on it yet. So I'm going to go to the Inspect tab into the Physical Properties group, and I'm going to go ahead and let it update the mass for this part. You can see right now it's over 76 pounds. I want it to be 60. So I'm going to go to Goal Seek and try to achieve that goal. Now, you can see now that I've got a whole list of things I can look at for my goal, and mass is currently my goal. I want to achieve a mass of 60 pounds, and I want to vary this guy until it gets to an optimum length so that the overall part becomes 60 pounds. So these are the variables that we want to seek for the goal. And if you look at the fly down, this dimension doesn't appear in there. And you're like, well, how come that doesn't appear? Well, the reason it doesn't appear is because that's not a locked dimension. Right now it's a floating dimension. And by floating dimension, we know that in synchronous, if we change this back face and pull it around, that dimension updates. So it's not a locked dimension, and for it to be used in a goal seek, it has to be a locked dimension. So we're going to go ahead and lock this dimension by either clicking here. I've selected the dimension, I'm going to lock it here. So that's one way I can do it. Another way I can do it is by looking at the PMI dimensions, and I can lock and unlock it here. Or I can also do it inside the variable table. Now that I've got a locked dimension, I go back to my goal seek, I fly this down, and I can see now that I've got a linear dimension. So I'm going to right click on that, and I'm going to let it go through several iterations of calculations trying to figure out the most optimum length to bring me to my 60-pound mass. Again, this is based on aluminum. And it seems like it takes a long time, folks, but to us now, with the computer era the way it is, and all the fast processors we have, 15 seconds just seems like too long. But if you consider what it's doing and the work that it's saving you, it's well worth the wait. So it's still going through its iterations, and there are ways to limit the amount of time that this thing takes. I'll show you that in a second with the options. There are options that you can set that will limit the amount of time or the number of iterations that you're going to allow Solid Edge to go through on the goal seek to try to find a solution. If it doesn't achieve it in those parameters, it will stop and it will tell you that it just couldn't do it. So it's found an optimum dimension of 9.433, and that gives me a target weight of 60 pounds. And here's the options I was talking about: maximum time and maximum number of iterations. So I could go and change the material and rerun this. If I changed it to iron, which is a more dense material, this block would shorten up after the goal seek is completed. So that's a very powerful tool, and I'm sure you'll find lots of uses for it. I can change the size of this by changing perhaps the angle of this face, and just by doing this I have changed the size of it. It's going to be smaller so that it should get a little bit longer to achieve the 60-pound mass. One thing you'll also notice, another enhancement in the live rules, is that they've added the colors for the different faces when you're using live rules. And this used to be in the help, and it wasn't real clear on where everything was. And when when your faces take these colors on, you can look at them and you can tell what these colors are just by putting your cursor over the little tool over here. And that you can turn that tool on by clicking on the live rules options, which puts up that solution manager over there on the corner. Now that works great for parts, but it also works really good for assemblies. So let's take a look at assemblies for goal seeking. To accomplish that, I'm going to go ahead and open up an assembly. This is one that's may or may not be familiar to you. We've used it in a lot of our demonstrations and in a lot of our training for Solid Edge. And it's our famous little carrier assembly. It's got a couple side plates and a block and a little mounting pin in between them. And so here's the setup for this thing. What I want to do is I want to move this side plate out in such a way, in this direction, in the Y direction, until the center of mass of this whole assembly is located at 100 millimeters in the Y direction from the origin. So that's what I'm trying to accomplish. I'm trying to accomplish a center of mass in the Y direction at 100 millimeters. So let's take a look at the variable table. Here is my adjustment for the offset for the mate between these two parts right here. And so if I change this to say 5, you can see that the part moves out 5 millimeters. So that's what I want to vary. I want to vary that and move this thing in and out until I find a position so that the center of mass of the whole assembly is at 100 millimeters in the Y direction. So because I do not have those that information in here, I want center of mass in the Y direction, I've got to go ahead and do the physical properties calculation. And when I hit update, it appears that the mounting pin in this thing, the pin in the center of that thing, doesn't have a material assigned. So I'm just going to give it the default material and let it go ahead and calculate that mass property, or all those mass properties for this part, for this assembly. So it's calculated the mass properties. Now if I look at the variable table, you can see that I have all my mass property variables in here. This is the one I'm interested in right here, folks, the COMI, the center of mass in the Y direction. I want this to become 100 millimeters by moving this side plate in and out. So what am I going to use? Again, the goal seek. Now the mass is the default from the previous time I did this, but I'm going to change it to COMY. That's my goal. That's what I want to watch. And the target number I'm looking for is 100 millimeters. Now what do I want to vary? Here I want to vary V164, and I don't have to worry about this being a locked or unlocked dimension. In assembly, these are all locked dimensions. They all control the model. So I'm going to go ahead and let that thing iterate, and you'll see that it's moving the side plate in and out automatically for me until it achieves a number that gives me a target center of mass in the Y direction of 100 millimeters. So let's take a look at 164 now and see about where we're at. It looks like we're about at 300 millimeters, so that's the position of this side plate, and perhaps now we want to add other things and keep things moving along so that our center of mass stays at a certain position or whatever. But the goal seek helps us find positional type things even in assembly. So in both part and assembly, the 3D goal seeking is a very powerful enhancement to Solid Edge. Another enhancement added in ST6 is tangency control handles. They've really enhanced the way you can control how the part comes together in lofts and sweeps and those types of things. When you're creating blue surfaces and those types of things, you really have a lot more control of how these surfaces come together. And to give you a little example of that, I've put together this little part that's got a couple of pieces already in it, and I want to loft a section between this part of the part and this part of the part, and I'm going to show you the different ways that you can utilize the tangency handles so that you can get what you're looking for. First off, I'm going to turn off that base so that it's kind of out of our way, and I'm going to go up here and do a loft command, and I'm just going to go ahead and use the edges of the part as my curves, and I'm going to go ahead and let it give me its default solution. And you can see now in ST6 we have these little dialogues that pop up. It knows that it can provide me more information and better ways of doing this. Right now it just kind of comes in and it does what's called a what type is this? This is a default or a natural. Specifies that there is no constraining condition enforced at the end, so it just takes it and just bams it into the next section and goes on. But you can see that there are 4 or 5 different settings here that we can use. Curvature continuous. So if I do that, you can see that it's taking the curve of this thing and it's continuing it on, so that we're getting a little more tangent looking. Well, this is actually tangent continuous, so that actually gives us a different shape there. And tangent interior, which makes it pop out and give you kind of an edge right here that may be the way you're looking for it. It kind of folds back in on the end section there. Let's see, I don't know if this one does all that much there. It looks a lot like tangent. I'm not really sure exactly what that does, but they all change the shape of the part and gives you a whole different look and feel. So let's go back on this one to the tangent continuous, and you can see there's also a handle here, and if you click on this handle and drag it, you can pull back where you want that thing to actually achieve its goal. You can't really go too far here. You can see as I move this thing, I'm getting different results as I pull this thing in. So you've got a lot more enhancements in here as to what you can do with this. Here's a handle here. Now I can pull this and change that shape as well. So with these new tools in Solid Edge ST6, you can really control the way your surfaces come together when you're doing loft sweeps and blue surface and stuff like that. Also in ST6, we have the ability now to do reflective planes, and what this gives you the ability to do is show a left and right hand part without actually having to go out and create the right and left hand part. So what it does is it gives you a view of the part in its mirrored image without having to actually do a mirror, a mirror part or anything like that. So and without having to do like an insert part copy with a mirror or any of that, you can get it right here while you're designing the part. And the way that works is by utilizing the reflective planes, and those are available in the Inspect group under the Analyze tools, and you can go ahead and show the reflective plane. Now the reflective plane right now is across the, looks like the ZX plane, but if you go to the settings you can change that. So maybe I want to show it in the right direction. So now it's just kind of over the top of itself, but if we change this number to say like 20, click OK, now I've got a left and a right hand. Now they don't look much like much because I don't really have any other features, but let's say that I was to put an extrusion right in here, maybe some trapezoidal shape here. You can see that. Oh, I've still got I've got both of them turned on, so it's giving me reflectivity over this plane and this plane. So if I go back to the inspect, go to settings, I can turn off the front view reflectivity, and now I've only got the side view reflectivity. So you can see that there's a left hand and a right hand part and what they look like and how they're going to look with respect to each other without having to go back and do a mirror or do an insert part copy with the mirror turned on. So one of the other enhancements, and again we're working on enhancements within part modeling, is the ability to recognize features, and I'm going to work in synchronous here, to recognize features from bodies that you may bring in from other CAD systems. And so what I've done is I've created a hole pattern part, and I've created an X underbar T. This started out as a solid edge part and I saved it out as a parasolid part. So I'm going to open it up like I'm opening it from another CAD system. And so what this part has is, and you can see that some of the features, some of the holes were suppressed, and that's a nice thing too. So Solid Edge has had the ability in ST5 and before that, it's had the ability to, under the hole, recognize holes in the part. So when you recognize them, it found 28 holes that were all pretty much the same size, and so it listed them all as simple holes with a 1/2 inch diameter. So if I click OK, it creates that feature set here in Solid Edge, and this is nothing new. This is nothing new. This has been in ST for a while. But what is new is the ability now to select that and create a pattern from that. So this is a new ST6 enhancement called Recognize Hole Patterns. And if I select that, it sees that that's a rectangular pattern. It allows me to define the master occurrence, which I'm going to put the master occurrence down here. So you can move the master occurrence anywhere you want to. And I click OK. And so it took that whole, all those holes, and it patterned them and created a hole pattern. So now I can move that whole pattern just with the steering wheel. I can move it back and forth and do whatever I want with it as a pattern. I can also go back and change one of the holes, like say for instance this guy, and maybe I want it to be a 0.375 hole. So now they're all patterned together and they're all making a pattern. Instead of having to just be a bunch of holes, I've got a pattern. If I want to turn one of these items back on that's suppressed, I can just go up here to the suppress instance, and you see that it's got an instance out there for me. So if I just click on that, it adds that instance back in, even though in the original XT underbar file, the parasolid file, the dumb body from another CAD system, that file didn't, or that hole did not exist. But it understands that that hole may have existed at some point in time and that you just want to add that back in. So again, that's Recognize Hole Patterns. Very powerful new tool within synchronous modeling. ST6 gives us some new surfacing tools, some enhancements to the surfacing capability. One being the ability to intersect surfaces with each other and trim based on selections from the user as to what you want to trim. And this really streamlines the trimming capability. You've always had that ability in Solid Edge, but now you've got the ability to trim and be specific about how you're trimming things. So what I've got is a couple of curves out here in space, and I'm going to go ahead and create a couple of just extruded surfaces from these, and from this one as well. and then just show you briefly how the intersection function works. It extends or trims the selected surfaces to common intersections. So if I select this guy and this guy, it wants to know, well, how do I want to trim? Do I want to trim like this section off, or do I want to trim this section? Do I want to trim the bottom or the top? I'm just going to let it trim the bottom, let's say. So just by doing that, it automatically trims those surfaces back and makes the trimming much easier. I'll go back and do another trim here, another intersection. We'll trim one other part of this. So if I click this part of it, it trimmed off that chunk of the surface there. And this can be done with multiple surfaces, so if you have several surfaces coming together, you can trim those all at once. So they've really made a really nice enhancement and streamlined the way that you can trim surfaces to each other. So that's nice. Now there are many more what I consider to be a little more minor enhancements. I mean, there was hundreds of enhancements to Solid Edge, and especially in the part modeling environment, but because we don't have time, we won't cover all of those. But there are in the help, you can look under what's new in ST6. There'll be a lot of things in there that you can read about, and there's just a ton of stuff. And so this is a really good update, ST6 in the part modeling environment. So next we're going to go on to the sheet metal environment. So sheet metal and ST6, here's some enhancements that they put in there we feel are pretty significant. One is the ability to put deformed features now across existing bends. And we haven't been able to do this in the past. It's given problems, and you've never really been able to make that happen. So what we'll do is we'll go ahead and show you a couple of examples of this. And to show this, I have created a simple contour sheet metal part here, just a simple shape. And deformed features in sheet metal, what they're referring to are things like drawn cutouts, beads, dimples, louvers, all those types of things are the kinds of things we're talking about, and they want to put them across bends. So let's start off by doing just a simple cutout. So what we're going to, drawn cut. So I'm going to go ahead and unbend to this face, that and that and that. So we'll just go back to a flat sheet so we can put some of these things in here. And we're going to go ahead and do a drawn cutout. And I'm going to actually draw that drawn cutout across this bend. I'll go all the way out here, let's say. So we'll check that off, and we'll allow it to come up, I guess we'll say. So I've got this drawn cut across that bend. So let's go ahead and rebend that and see what we get. So you can see that it's taken that feature and it's wrapped it around that bend and given us a really nice representation of what that might look like if the drawn cutout was put in before the bend was placed. Same with like a bead. Let's say we were to put a bead. I'll use my A key to get me the arc command. So once again, rebend that guy. You can see that it's that. Now to make that happen, to have to model that would be a lot of effort. So they've saved us a lot of effort on that guy. Likewise, something like, say, perhaps a louver on this face. Now let's make that perpendicular. Louvers for me are always kind of challenging as to whether I get this thing set up exactly right, but Let's see what happens. Nope, the height isn't quite right. I always mess this up. There we go. So I put this was a sweeping bend right here, and I stuck a louver on the flattened part of that bend. And so now let's go ahead and rebend and see what it looks like. It's taken a while to think about that guy. But it did it. So very nice sheet metal enhancement. The ability to put deformed features across bends and have them rebend up. And again, the flat pattern, let's make sure that that works. So create your flat pattern so that you have placement for the locations for those deformed features. And you can go ahead and create the 2D drafting for that, or the DXF file for sheet metal folks to make their thing, get their part of it done. So very nice enhancement. Another Solid Edge ST6 enhancement in the sheet metal environment is the ability to create an emboss in your sheet metal part. So the setup for this, I'll give you the setup for this was, I'm going to go ahead and suppress this for now just so you can kind of see. There's a plastic cover. This has been in the tutorials for years. It's a plastic cover. It's been thin walled out. And so the setup here is that I've got this cover in my assembly that I want to put a sheet metal top over it to protect it, or for whatever reason I want to put a top over this thing. And it's going to sit a certain distance up, but I want it to take on the shape of the top of this cover. In other words, my sheet metal part, I want it to be stamped so that it takes on the shape of the top of this cover. And this is embossing. This is what's called embossing in ST6. So I'm going to go ahead and unsuppress this and show you how I set up this box. I just created basically a tab that I started a certain distance off from the ZX plane, and I created a tab, and then I did a contour flange around to get the sides of this thing. So once again, I want this shape to be embossed onto this surface right here. So it's really a relatively easy thing to do. In the home group under sheet metal features, at the bottom of the drawn cutouts and all those deformation type features, you'll find emboss. And once you have two bodies in there, and again, the thing I did was I put this cover in with the insert part copy. I guess I should show you that. I just did it with an insert part copy, and I brought it in as a construction body. Okay, it's not in there as a solid, it's just a construction body so that I can use its surfaces for the embossing. So once that was in, then I built the sheet metal box that I want to cover that thing with, and then I want to put the emboss in there. So I'm going to start the emboss command, and it's asking for the target body to be embossed. Well, that's my sheet metal part. Now it's asking for the tool body or bodies, and this could be more than one body. But I've only got one body, so I'm going to go ahead and tell it a clearance of maybe 10 thousandths. I want the thing to clear it by 10 thousandths, and just as you would think, it has created an emboss on top of that box, or that box shape has taken on that embossing. And even if you flatten it, that embossing will stay there. Whoops, I didn't get that base there. that embossing will stay there, and then you've got some locations for the tool to stamp that into the sheet metal part. So again, embossing, nice, very nice function that they've made available for us in Solid Edge ST6. The next enhancement in ST6 sheet metal we'd like to show you is the ability to create a contour flange on a contour flange. So to set this up, I created a tab which is basically this shape right here. I'll go ahead and show you what that looks like. I created a tab that had that shape. Then I created my contour flange, the first contour flange, to give myself kind of a thing here. And now what I want is, I want a little ditty sticking out here, a little shelf on this thing that goes from here around the corner over to here. So once again, I'm going to go back and create another contour flange, and I'm going to start, and sometimes this works and sometimes it doesn't, and I found that if I use the outside corner, the edge of the outside of this curved surface, that I get a lot better results. So I'm using that as my plane normal to curve, and then I'm just going to go ahead and draw. Let's put a dimension in this thing just so we can control this. We'll go 1 inch. So I can move this thing around so that it it creates the flange around this edge right here. But if I chain it, I can go here and chain that all the way around there. Now it says this deformed flange will be created on the selected curved edge. By default, the deformed flange will be applied to any curved edge being swept. I'm not really sure exactly what all that means, but I'm sure it has something to do with the downstream flattening or whatever. But you can see that I was able to put a contour flange along the edges of an existing contour flange by using this new enhancement in ST6. So to finish up here, we want to talk about one more enhancement that they put in sheet metal, and that is the ability to flatten parts whose features may lie on a curved surface. So I'm going to open up this flatten PSM file just to give you an idea what this looks like. So in this example, what I did was I created a contour flange, then I unbent this bend, dropped a hole in that surface, then I unbent this surface, or this curve, this bend, and I dropped a normal cutout in there, and then I rebent everything. So in the flat, these edges should all be perpendicular to the sheet metal. But it's representing right now like these holes are represented as curved surfaces, basically, just like you would expect. So when we go ahead and do the if we go ahead and do the flatten pattern, you'll see that it takes everything back to its normal two surfaces, just like you would expect and just like you would need to go ahead and create your flat sheet metal part. And if I'd have been a little more on the ball, I would have had my little cutout have a little more of a smile to it to indicate that you should be smiling now, because this is a great release of ST6 of Solid Edge. So that pretty much wraps up this Lunch and Learn. Again, this is part 1 of 2. Next month we're going to talk about the enhancements in ST6 with respect to the assembly environment and the drafting environment. And I will tell you that the drafting environment is very exciting. Some really nice things in drafting have happened for us in ST6, and I know you're going to be excited about that. On the behalf of Acuity Solutions, I'm going to sign off. This is Mike Ritzer. Thanks a lot for being our customer and for attending this month's Lunch and Learn. Have a great day.